lesson where we are going to be discussing some properties of trapezoids. You should have the words filled out in your math dictionary. You would have been given this diagram of a trapezoid where the sides that go from top to bottom, we call them legs. We have a base and a top base, and the base angles are the angles that are on those sides. So an isosceles trapezoid is if two legs are congruent, then both sets of base angles are congruent. So in an isosceles trapezoid, isosceles triangle, two sides are the same. Same thing with a trapezoid. If that is the case, then the base angles, the bottom angles here, are going to be exactly the same. Our other property is called the trapezoid midsegment. The midsegment is the line directly in the middle of the trapezoid. Its length is equal to the sum of each base divided by 2. Another way of writing that, this middle segment, xy, the length of it is going to be equal to the top base of BC plus the bottom base of BAD. And we can multiply it by 1/2. When you multiply something by 1/2, it's the same as dividing by 2. Let's get into some examples. Example 1, given the isosceles trapezoid, find the measure of each angle. So we're only given one of the angles. Let's be reminded of our polygon angle sum theorem. We may need to use that. Let's use our definition of it's an isosceles trapezoid. That tells us that the base angles are equal. So if we use this fact that angle A is congruent to angle D, then I should know that angle D is going to be 71 degrees. Now, using that polygon angle sum theorem, we know we have two missing angles. It's a four-sided figure. So if we do our 4 minus 2 times 180, that would give us 360. So we know that if we add all of the angles, angle A plus B plus C plus D, it's going to equal 360. Well, we have 71 here. We've got 71 here. Our total for the whole thing is going to be 360. So what if we just take away that first 71 and the second 71, we'd get 218. Another way, you could add these two together and then subtract. We'll still arrive at 218. So I know that angle B plus angle C equals 218. From our isosceles trapezoid property, I know that those angles have to be equal. Well, if they have to add to 218, I know that they have to add to, they have to be equal. Therefore, I should just cut them in half. Cut that number, 218, divided by 2, gives me 109. So angle B and angle C are both 109 degrees. We can double check by adding up these four numbers. Take a moment, put them in your calculator. Guess what? We get 360. Checks out. Example 2, using the mid-segment formula for a trapezoid, identify the length of each missing value. Well, our mid-segment formula is that mid-segment is going to be 1/2 times the two bases that added together. In this example, we have 37 for this base and 51 for the bottom base. So if we use our formula, EF, mid-segment, equals 1/2 times AD plus BC, and I replace those values, so 51 for AD, 37 for BC, we're left with EF, so to figure out this length, it's going to be 1/2 times 51 plus 37, which equals 1/2 times 88, or you could think of it as 88 divided by 2. Either way, EF is going to equal 44. Example 2, we have a little bit different. We know the base, and we actually know the mid-segment. Now we're just trying to figure out, well, what's the length of this base? So let's utilize our formula and plug in what we know. EF, we know, is 37. BC is 32, so I replace that. Now, in this scenario, we need to solve for this. So in order to get rid of the fraction, what I like to do is if I have 1/2, that's my fraction, if I multiply by the denominator, so if I multiply this side by 2, and I multiply 37 times 2, So I'm basically multiplying everything by 2. That will leave me with 74. 37 times 2 is 74. And then when I multiply this by 2, that 1/2 cancels out when we multiply by 2, leaving us with just what's on the inside, which is the AD plus 32. We can subtract 32 on both sides and give us the base of 42. Example 3, we got a little bit more going on here. The first thing I know is that angle B and angle C are equal. That makes finding x easy. It's going to be 110. Got a little more to do to figure out angle A and angle D. But before I solve or try to confuse myself trying to solve for y here, I'm just going to solve both base angles like we did in example 1. So if I add them all up, it's going to be 360. Take away the 2 angles that we have, we're left with 140. So A plus D has to equal 140. They got to be the same, so let's cut 140 in half. So we know that angle D is 70 degrees, and we also know that angle A is 70 degrees. Now that I know a number that this expression is equal to, I could set up an equation. Angle A equals 70. Our expression for angle A was 3y plus 27. We set it equal to 70, and now we can solve. Subtract 25 on both sides, divide by 3, and we would get y equals 15. So sometimes we need to find the angle measure before we can come up with an equation to solve. If we tried to solve this on our own without that information, we wouldn't be able to. All right, example 4. Utilizing the same thing. Okay, angle A equals angle D. See how they both have an x involved? So our equation, I could set them equal to each other to solve for x. Now notice, my first step would typically be to subtract 7x here. But 5 minus 7, that's going to give me a negative x. I don't want to deal with a negative. So I can flip-flop them. That's the beauty of the equal sign. It doesn't matter which side I put it on. So I'm putting the 5x plus 21 on the right and the 7x plus 5 on the left. So that my first business is going to be to subtract 5 on both sides, leaving me with a positive 2x, because I don't like dealing with negatives. Now I can subtract 5 on both sides. 2x equals 16, so x is going to equal 8. Now that we know that, we plug it back in. So angle A was 5x plus 21. Replace the x with an 8. Angle A is 61 degrees. Follow the same process to find angle D. Plug in the 8 for the x. And we get angle D also equals 61. If we needed to, we could find these angle measures using a similar process that we did in example 1.